Hello everyone, welcome. Today I'll explain what an MCP is. It's a Model Context Protocol, a new standard that's become popular in recent months. It's designed to connect AI applications with external tools and data bidirectionally. In this guide I found in the templates which shows how an MCP flow works. You can take a look if you want. Well, MCP was actually introduced by Anthropic, the creators of Claude, right, in November 2024, so quite recently. Its goal was to standardize communication between language models, LLMs or AI agents, and external apps, services, and data sources. In other words, they provide a universal interface for AI agents to access data, files, databases, and more, right? So what does that mean exactly? Well, instead of creating a flow that integrates AI to perform a task, make a decision, or identify an error, what we're doing with an MCP is giving an AI agent access to our entire workflow or multiple workflows, allowing it to make its own decisions. Got it? This lets the AI navigate through various processes independently, okay? That's why it's so innovative. So why is a protocol like this necessary? Previously, integrating AI with different tools required custom connectors for each API. Right, that's what I was saying. This created what Anthropic called the NXM integration problem. For NAI applications and M services, meaning each AI used would require multiple services. It was hard to scale, like a spaghetti of connections, solved by MCP's common language. That's another thing, right? Different APIs have their own languages, you know? Now we're talking about how this language unification optimizes work even more. So MCP was born to solve this by providing a common language. With MCP, a dev can create a server for Slack, Gmail, etc. Any AI can use it, be it ChatGPT or Claude, instead of using dozens of fragmented integrations. Alright, let's explain how an MCP works, okay? An MCP follows a simple yet powerful client-server model. The key components are the MCP server and the MCP client. What's an MCP server? It's a lightweight program that exposes the capabilities of a specific app or service. For instance, you can create a server for email, Slack, Google Calendar, a database, and so on. Here we're looking at the MCP server and how it connects to various workflows. This server tells the AI agent what it can do with these tools. It specifies readable data, resources, actions, tools, and how to use predefined commands or flows. Basically, the prompts. Basically, think of an MCP server as a translator or manual for the tool, which the AI agent can contact, okay? Or communicate with. Then we have the MCP client, right? That's the AI app or agent needing to use the tool. Here, an MCP client connects to an MCP server to ask what it can do and then send instructions. For instance, Claude Desktop, ChatGPT, or an N8N flow with an LLM node can be MCP clients. Got it? Here we'd have an LLM node, for example. The MCP client orchestrates the server conversation, managing context and requests. In Anthropic terms, the AI agent is the MCP host, while platforms like N8N act as MCP clients connecting agents to servers. The key concept is that the LLM agent and MCP client server form a communication bridge. MCP ensures this bridge is secure and bidirectional. The agent first asks the server about available tools and data, receiving descriptions to automatically learn their use before sending command. Let me give you an example to help visualize this better, okay? I know it's a bit complicated. For example, MCP is to the digital world what the USB-C connector is to physical devices. I'll show you this connector here. Before USB-C, each peripheral, screen, external drive, charger, etc. needed a different port and cable. Having a laptop meant dealing with multiple ports and compatibility issues. With USB-C's arrival, one standard port allowed connecting all kinds of devices with the same cable. MCP aims to be that universal connector for AI agents. Instead of learning a new language or connector for each API or service, agents can use one protocol to plug into any external tool. Lastly, it's important to note that MCP is an open and collaborative standard. Since launch, it's been quickly adopted by industry, major companies, and communities like OpenAI, Google DeepMind, Microsoft, and others. They announced MCP support in their systems for 2025. There's even an open repo with ready-to-use MCP servers for popular tools like Slack, GitHub, Git, Google Drive, PostgreSQL, Stripe, etc. This means there's already a base of MCP servers available for many common apps, which we'll see an example of in these cases. So that's a brief explanation of how it works. In another video, we'll look at the specific, more visual functionality within N8N. Remember, N8N link is in the description. Check out my N8N course. See you. Very well. CCMs versus traditional APIs, differences and advantages. At this point, we might wonder how using the usual API is still different, right? After all, we could already connect AI models to external services via API calls or specific integrations. The key difference is the MCP standardization and two-way communication, which transforms the integration experience for both developers and AI agents. Okay, for those who aren't following, let's break it down, alright? In AI, you access an app, and as you see here, we can act individually in each of these apps. What happens? Each app has its own variables, activities, actions, and so on. An MCP takes all these languages and unifies them. Got it? How does it unify them? Basically, the MCP teaches an AI agent how a tool works, and once it understands, it'll use it independently. Got it? To put it simply. Alright, universal standard versus custom interactions. With traditional APIs, each service is unique. Say you want your AI assistant to send emails and messages, you'd have to program email and Outlook APIs separately, each with different docs, auth, and formats. Add WhatsApp, Slack, Twitter, etc., and the work multiplies. Each API has its own methods, parameters, and error codes to learn and manage. This is the language chaos we're talking about. Developers had to be API polyglots. MCP, however, acts as a universal interpreter. Once a service offers an MCP server, it speaks the same language as any other MCP server. The AI agent doesn't need specific code for each integration, it just connects via MCP and the server tells it what functions are available. For example, you can use a function to send a message that needs text and a channel, etc. This drastically reduces integration effort. Learn MCP once and it works for everything, got it? 2. Two-way communication versus one-way calls. In a typical REST API call, communication is one way. The client sends a request and gets a response, but the API doesn't teach or correct. It just returns data, confirms, or gives errors. So with MCP, the exchange is richer in terms of information, okay? When an AI agent connects to an MCP server, it first gets a list of tools and resources with usage instructions. That's what I was explaining, right? First, we get a brief intro on how to use the tools at our disposal. Then it's like automatically getting API docs, but in a format the AI can instantly understand. If the agent tries using a tool, the MCP server can respond with results, standardized errors, and usage guidance. The agent and server keep talking while the task runs. The agent can query, execute, read results, and query again, etc. all in one session. This is crucial for autonomy. The LLM can figure out how to use the tool on its own. In short, MCP adds intelligence to integration. The API becomes an active collaborator guiding the model, not a black box. We also found it results in less code and fewer long-term errors, right? Basically, MCP doesn't replace APIs, okay? It still uses them, but indirectly from the user's perspective, you see? This revolutionizes how we use APIs. We can now access any app in a standard way instead of using separate recipes for each API. LLMs expand their limits, moving beyond static knowledge to act more intelligently in the digital world. Alright, let's talk about MCP in N8N, how it works and how to use it. First, we'll go to templates, okay? And we'll search for MCP here, alright? As you can see, there's already a dedicated section. I've chosen this build your own N8N workflows MCP server, okay? Just click here, use, then copy, go here and paste with Ctrl+V, okay? And it'll paste right there, got it? See? I've got it pasted now. That's it. Okay, let's go back. Great. N8N now supports MCP, letting you use external MCP tools and workflows and share N8N flows as MCP tools, okay? Here we have the MCP server they've included, as you can see. This works mainly through two key nodes, the MCP server trigger and MCP client tool, okay? There they are. The MCP client tool and the MCP server trigger. This is a trigger, okay? How do we know? Because it has a little lightning bolt. Oh, look, that one's also a trigger. And then there's the client tool, right? Let's see if I can add it. Ah, here it is. MCP client, see? This is the client that connects to the AI tool. Basically, server trigger triggers the server and client tool is MCP's client tool. Got it? According to N8N docs, these special nodes help AI agents and external services communicate easier. Next, we'll explain each one and how to use them with examples. MCP server trigger acts as an MCP server within N8N. By adding this node to a workflow, we're opening the door for external AI agents, or MCP client, to use that workflow as a tool. In other words, it turns your MCP toolflows action nodes into something external agents like ChatGPT or desktop can use. So how do you set it up? Basically, we add the node, create a new workflow in N8N, and call it MCP server or something similar. When we add the node, N8N automatically generates a unique URL endpoint, which is this path. That URL is what MCP clients will use to connect. For example, it might look like, here it is, sorry, localhost MCP test and so on, okay? You can customize the path if you want, though it's not mandatory. You can also set authentication to none for testing or use bearer token. Use headers if you want only authorized agents to access. Then we'd connect the tools or nodes we want to expose. This is the crucial step. We need to connect to the MCP server trigger, the nodes representing actions or data you want to offer the AI agent. For instance, say you want to expose the ability to send a Slack message and create a Google Calendar event already set up in N8N. In your workflow, you could have a pre-configured Slack node to send messages to a specific channel, and a Google Calendar node to create event. Connect them to the MCP trigger, create a connected node, and basically link them to the MCP, the external agent. This way we can connect various custom functions and more, okay? Basically here they show us how to add workflows using their ID, right? The tutorial itself demonstrates this right here, got it? Alright, then we'd activate the workflow, okay, and obtain the SSE URL. When everything's set, activate the workflow. The MCP node's server trigger will show the production URL, the SSE endpoint. This is how MCP maintains continuous client-server communication. The URL shown is the address you'll give the AI agent to connect. N8N also shows a test URL when in listen for test event mode. Finally, we test the connection and everything else. Before using a real agent, you can test it yourself. An easy way is using curl from the terminal to make a post request, okay? After these steps, your N8N becomes a ready MCP server. What does this mean in practice? Any external AI agent like Claude or ChatGPT can now use the tools you expose. Alright, so in the explanation provided here in the template, there's more to it, right? For instance, we can execute from another workspace or have it run by a different workspace. We can also allow the agent to run any N8N workflow, right? It can work with any N8N workspace. They show us a bit of everything here, including all the variables we need to set up. Then, of course, we'd connect the AI agent here, and that's it. Now we know the basics of using an MCP for N8N.